Today we start with two speakers, Patrick and Michael, and let me introduce them. So Patrick is a DevOps engineer, blogger and lecturer as well. He loves to automate everything. Great. He's responsible for the CI/CD, cloud, container, and Kubernetes topics in his department. And he also supports I love that, the local football club with visiting their plays and watching their matches. And Michael also has a sound technical has a lot of technical education, starting from the University of Graz as well, and more than 15 years of practical experience as well in software development, setting up quality assurance department, working internationally as technical project manager, and also working with requirement engineering. This is, I think, a very great background as well. And he's been familiar with the introduction of agile for more than 10 years, driving the focus on quality and also continuous improvement, which I think again comes hand in hand. And of course, Michael is also a sport guy, right? Biking around up and down in the beautiful hills around Graz. But I'm sure that's more on the vineyards, and you are tasting as well. All right, guys, the stage is yours. Migration of a containerized legacy application to the cloud. So please share the screen. I stop sharing here.
Right. Thanks a lot for a kind introduction. I hope you can already see my screen. You can hear me and you can see me. Okay.
Perfect.
Okay, great. So welcome to our sessions. Thanks for giving us the opportunity. Today we'll talk about doing DevOps for a legacy application. In particular, how we build containers in a DevOps landscape and finally bring them into the cloud. Of course, we will mention the technical challenges as well as some interpersonal challenges we faced during our transition phases. We will also try to prove that we did it. And we believe that there are still many legacy applications out there, and we want to encourage you that migrating to the cloud, it's possible. Even though that we're listing the soft skill part, we will rather highlight more technical aspects. That is today's agenda. We will start with an introduction. We will discuss different phases of our transition phases. We'll present the current status and we'll conclude with a roadmap and an outlook. Before we go into detail, let's introduce ourselves very briefly. So we work for AWL List in Graz, Austria. So as already mentioned, we are Austrians. You might have already noticed it from our pronunciation. In the box here, you can see a few key facts about our company. So basically, we do development, simulation, and testing in the automotive industry for a very long time. Every car manufacturer or company that has anything to do with engines are our customers. But latest with 2021, 22 COVID years, plus the climate crisis, the whole world is facing significant environmental, sociological, and technological challenges. And we already know a combustion engine is probably not our future. So we in our company can see that we have to face new challenges: electrification, autonomous driving, emission, vehicle data intelligence. Of course, those are just some keywords, but I think most of them are well known to you. And the change is also affecting the whole infrastructure and also software development. So we don't only do hardware, yes, we also do software development in our company. Who we are, we already got an introduction, but maybe let's do it again. Patrick.
Hi, my name is Patrick Koch. I've been working for AWL since 2014, and my official job title is Integration Engineer Software. But as Szilard already mentioned, thank you for that, my daily work is about DevOps activities, among others, creating CI/CD pipelines, adapting them, replacing virtual machines with containers in our infrastructure, and respectively working on container solutions for our software application. In addition, I'm also acting as some kind of Kubernetes admin, and since last year, I'm also dealing with cloud topics.
Let's do it again. So my name is Michael Mitter. I've been working for EVL for more than 7 years. I'm currently a product owner, team lead, and responsible for Scrum team. I think you can sum it up simply. I'm the agile servant who always tries to stay on top of things. In my role, I'm responsible for planning, so sprint and iteration planning, responsible for release integration management, DevOps test management, and software quality. And as already mentioned, as a balance to my business work in my private life, I like to do sports, renovating an old house, and I love listening to heavy music. The louder, the better, so to say. Right. I've mentioned challenges, and usually when you do a technical transformation, also some social changes are happening, right? And therefore would like to briefly highlight these aspects. Let's go about back 7 years. What was we as a company decided to switch from the classical waterfall development process to agile. Sounds great, of course, for this or for those who were willing to join this transformation. For some, it was completely incomprehensible why we do this right now. Instead of having one team, we had suddenly 3 teams, even distributed, and we also had different levels of experience. You can imagine the atmosphere was quite explosive. A youngster from university had to collaborate with a developer being there since ages. Also, new roles like product owner, agile manager, agile master were introduced next to existing additional roles. Okay, great. So the process seemed to work somehow. We got some guidance from our agile coach. And then we thought we are ready for the next step, introduce DevOps. So it's much more technically. Also here we faced a problem, but this time it was a mindset problem. We saw an initial resistance coming from the teams to move to DevOps just due to the fact that they were used to things in a certain way for years, if not for decades. They really asked, why do CI/CD for what exactly? And our management guys tended to simplify the problems and often rely on examples from the open source world because, of course, there's much easier to get free software, download it, and work with it. At the end, we realized that legacy will remain part of our software, of our landscape. We simply couldn't throw away our engines, and therefore we needed to implement DevOps around the legacy software. So now, despite becoming agile, trying to solve the mindset, we also started to introduce completely new set of tools. And I'm sure you know already that tools don't magically solve problems, but if you use it in the right way, processes become more efficient, right? And in our case, and that's really true, we didn't have to call someone to get a new build because suddenly we have this CI. A build was created right after your commit, and then we had suddenly full transparency. So we survived the change regarding organization, tool chains, and so on. What was next? We were actually doing quite well with the desktop application, and then we were increasingly confronted with new challenges and new requests. To get an idea why we always talk about legacy, let's briefly mention the application we're developing for. And no worries, there's of course no promotional event, but it's worth to mention it once. So the software we are developing on is called Concerto, AVL Concerto. And I would say it's an advanced data processing platform with a wide range of capabilities. You can harmonize, you can standardize, you can search for data. So it's all about data. You can do reporting, calculations, fully automated data evaluations, and you can run your own applications. So the automotive industry, so to say, has quite some special data formats. And why now legacy? You can see here the development has started more than 25 years ago. I think it's already 29 to 30 years ago. Some young colleagues were in our team even not born yet or were still at nursery. So it's having a very long, very huge history. More than 7 years ago, some changes were happening. We decided that the product should evolve to a platform product. We got a new managed UI layer. We introduced support for Python scripting, added a REST interface, and an automation framework. And some time ago, we started to deal with containers, managed cloud environments, and recently we also started a relationship with the pension. But more about this later on. So as a basis, we have still a C, C++ legacy core architecture, so to say. And I would say it's a desktop application typically installed and running on a local client. Nothing new so far, right? I have to admit that we have neglected the topic of cloud for a very long time and thought on-premise will always have priority, and it's not possible to bring our application into the cloud. In the automotive industry, we had this kind of conservative mindset, I would say. But after more and more customer requests, it was clear that we couldn't do it without the cloud. So our mission was then, let's bring our application into a cloud framework, find a strategy, and start right now. By application, I really mean our good old boy who's no longer the youngest. So here are a few key facts, cloud adoption statistics for 21-22. I guess you already know them. So by going through them, I think it quite clear the question to answer whether you have to migrate to the cloud or not. And I would say it's a clear yes. But in our special use case, what were the motives? As already explained, the application is usually getting installed on a fat client as a desktop application. But also we thought that these days everything needs to go faster and needs to run in parallel, right? So also for our application, it was necessary to adapt, to provide support for automation and allow scalability. And our customers requested to automate existing applications instead of manually execute them on single installations. Also, the amount of data is drastically increasing, but for sure that's not valid to resources. So the main question was really how to run our application on a large scale. It's an office application. Quite soon, we did the decision, let's see whether it's possible to containerize this legacy application. But can this be effective? I'm sure you know it, for getting your existing application into a containerized solution and then use it in a cloud environment, of course, you need a container, right? And therefore, you have usually several approaches. First of all, refactoring, rebuild, or lift and shift. Rebuild, honestly speaking, was never a real option, at least not at the moment. So we asked ourselves, is it possible to refactor the entire application in just a short time, thinking of its long history in order to get it modular enough so that it fits in a microservices architecture? We agreed then at the moment refactoring won't work due to different reasons. And therefore, we've chosen the lift and shift model. And this simply means the entire application gets pushed in a container. So by doing this, we had then suddenly a Windows container. And this was the starting point of our container adventure, so to say. What were now the advantages of this special approach? I know you know vertical scaling, forget about it. Vertical scaling simply means you can add more power, CPU, RAM to an existing machine. And in the long term, this makes no sense for a large number of jobs, right? So let's go with horizontal scaling. Scaling simply means here adding more instances to your pool of resources. And of course, scaling is one of the great benefits of the cloud. Scale up when there's a peak in your workload, scale down if it's quiet. Of course, this also only makes sense if you have a specific number of jobs. But even with our Windows container, you can then really optimize your IT costs. You do not have to take care about installations as the container gets shipped already pre-configured, right? How was this accomplished? Here you can see a typical cloud scenario of a hybrid cloud environment. We have here a message broker. This guy is a Linux container. He's doing the job administration. He's communicating with our scalable amount of Concerto instances running as Windows containers. And for data, the data server, he's the guy consuming and storing measurement data. This server can be either in a private cloud or it can also be located in the public cloud. Since we do data evaluations, we get a report as a PDF result at the end. And if you don't believe it that we actually did it, I would like to ask Patrick to prove it.
Hi, we are Eficode and we organize the DEVOPS Conference. Delivering the benefits of DevOps through cloud gives the scalability, availability, and cost effectiveness we all want. We would love to speak to you to learn how we could help you to do DevOps better in the cloud. You can find us at Eficode.com. The links are in the description. And have a great time with the DevOps Conference talks.
All right, as mentioned, let's prove it by showing you short demonstrations of our, let's name it, Cloud Microservice MVP. At first, the question is, how do we get our, in that case, Azure Cloud resources? So how can we create the necessary resources like a Kubernetes service or a container registry or a storage account and so on in the cloud? We've decided to use an infrastructure as code approach and have chosen Terraform as dedicated tool for that. So we are using so-called configuration files of Terraform to define the resources to get it done. Of course, we also would like to achieve that in an automated way. Therefore, we implemented proper Azure DevOps pipelines for applying the Terraform configuration files. And this allows us to provision our cloud, our infrastructure, of course, in the cloud and not vice versa. But how does it work in real life? That's what I would like to show you on the next slide. So here on the right, you can see the Azure portal. Currently, there is no Kubernetes service deployed. And on the left, we are now going to trigger a pipeline in our Azure DevOps server, which simply conducts the dedicated Terraform commands, which would be in that case the Terraform init for getting the backend established, and afterwards the Terraform apply for doing, let's say, the real provisioning of the Kubernetes service. So this works fine in an automated way, as mentioned. But after creating the necessary infrastructure, it would be, of course, time for running our containerized concerto and conducting the use cases of our customer. So this microservice to which we refer is based on best practice approaches, because we simply don't want to invent anything if proper templates already exist. As you can see, the Kubernetes service is now ready. So let's try the customer use case on it. And a basic idea for the related microservice can be seen on the next slide. So this picture refers to an example which Microsoft published on their webpage. So we start with our existing application on the very left, which is our containerized concerto in that case. And we need to provide it, of course, so the corresponding concerto container image at an Azure container registry. And by applying the proper CLI commands, in our case, it's kubectl, we are able to deploy our workloads at the Azure Kubernetes service, which we provisioned before. And again, let's see how does it work in real life. How does a part of the customer use case look like in real? Again, it's a short video. So on the right, you can see an already provisioned Kubernetes service. On the left, you can see a file share. At the file share, we get the result of our use case. It's a simple report for a customer. And now let's try to apply two different workloads at the Azure Kubernetes service. Because imagine that the customer would like to start two different calculations with Concerto. Therefore, of course, we need two different workloads with the corresponding pods and containers. And so inside the workload, we get our running Concerto doing the proper calculation. As you can see, two different workloads are now triggered. They are in a running state. Let's check the first one. There you can see that the pod is, of course, already running. Therefore, we can switch to the file share at which we get a first directory. So inside this directory, we will get the final report, and this directory is the corresponding directory for that workload. And of course, we will get a second one. So let's again check the second workload, which is also running. So therefore, the second directory occurs. And then let's wait until it's finished, and then we should see two different reports in the directory. So here we go. That's the very first one. Let's download it And let's open it. You will see some diagrams and tables, including the results of the calculation. And let's prove that also the second workload, which is finished, generated a dedicated report for our customer. So let's open it. And as you can see, it's a different one because of a different calculation. So this video shows how we run our Windows workloads in that case due to the customer need. And this works so far, but of course the development goes on. So what's next? We proved our, let's call it microservice MVP in the cloud, including Windows containers. And this mentioned implementations work well, but was the trigger of those improvements based on technical aspects only? Sure not. It was driven by business. For centuries, our main automation use case could be applied by provisioning a single Concerto instance for an engine testbed. That's what you can see on the left side at the picture. So casual requests to the Concerto instance from the engine testbed resulted to the start of the data processing, so to the calculation. And there was never worry about a bottleneck according to the amount of resources. And that use case changed in a dramatic way due to the rising demand according to electrification. Now it's not about verifying a single testbed only. It's now all about the battery engines. In contrast to the use case, or to our old use case, including the engine testbed, it's not mandatory to increase our Concerto instances by a factor of 100 or maybe 1,000. We're not that sure about the number, to be honest. And the right picture shows a factory containing multiple battery testing chambers. Each chamber includes several batteries. Each battery consists of several modules, which include different cells. And this results in a huge amount of data that has to be managed. And in contrast to the single engine testbed, which was our old device under test, it's now about multiple test cells, which are the new devices under test. Therefore, we need to immediately be able to increase the amount of Concerto instances. And if there is no need for doing a calculation, we simply have to free our resources for saving costs. Therefore, the prerequisites are be able to scale the resources and be able to provision the resources on demand. And therefore, cloud, respectively Kubernetes services, are predestinated for those requirements. But how can we increase the degree of automation?
Right, that's really the question. So how to increase the degree of automation? We can't do it with our Windows container anymore, right? This guy is not lightweighted and not ready for a future use case. But what's the solution now, right? Refactoring. But of course, not the whole application, just the core components. And refactoring, all well and good, but it's not enough. Let's make sure that we can cross-compile it and run it on Linux. So at the end, we really want to have a lightweighted Linux container instead of this Windows container. But what does our architecture look like then? On the left-hand side, you can see the, in principle, old architecture, which we had in place, lots of GUI components, old-fashioned, outdated interfaces like a COM interface. So really took only the core component, the native data management system, which is luckily written in C, C++. And we're the experts in handling of data of all kinds. And therefore, we really threw away all other components because in the container, you don't need GUI, right? And for data manipulation itself, Python is the language of choice. So why reinvent everything? Just let our core components communicate with Python modules. Of course, we also want to build our own modules, but in principle, that's it. So as you can see, we've really taken a drastic step here. We now know the architecture and of our container, but what does a future use case look like? Patrick will now give us an overview here.
Thanks, Michi. So our native data management subsystem will be in the focus with regards to our future architecture, respectively our future workflow. So let's throw away all the components which we don't need around the core elements. And so how does it look like according to the future architecture? Again, we start with implementing it in the cloud, for instance, in Azure. But we need, of course, something for doing the orchestration, Therefore, the AKS will, of course, stay, which will orchestrate our new Linux container, including the native data management subsystem, which can generate the desired reports for the customer. But how will the customer trigger the use case? For sure not, he will use the kube control commands. But we know that the customer would like to work with Prefect in that case, which is capable of running Kubernetes flows. And this will trigger the remaining chain. So that's about our future use case. Let's recap our journey of the previous years, and let's in addition check what will come in the future. So in 2019, we started with the containerization of Concerto. In 2020, we invested much time according to CI/CD to deploy the container on a productive system. In 2021, we started our proof of concept with Microsoft as a joint venture to get this microservice in the cloud done. In 2022, so in this year, we did our first development of the Linux container, and we also started with Python integration and to get it done with Python. And we are aware that it will not just be about Azure. We also would like to be ready for other cloud providers. And this will happen in 2023 in a more efficient way, I guess. And yeah, we also would like to really establish the Prefect workflow in this year. And this finally brings us to our last slide, at which we simply derived some key learnings due to social and technical aspects. Maybe as we're running out of time, let's just pick one of them. So don't reinvent the wheel. So if you would like to scale your resources and host it in the cloud, that's great, but use existing technologies and approaches. So don't invent anything. MVP first. We recommend to, if you're in a situation as we in the past, let's try to achieve the breakthrough first and ensure that the whole system works, because you can refactor afterwards. Let's pick infrastructure as code. This allows you to enable pay-as-you-go and software as a service. We used Terraform for that, which works great. We could also recommend it. Don't copy, respectively rebuild established tools. Please use established tools, for instance, for enabling the orchestration. Don't invent anything which already exists. Instead of that, keep focusing on the key features which defines your software. Architecture driven by business. So our main driver was, of course, the business, the customer. The customer sets the requirements, and we just tried to follow and adapt the technical stuff. And according to social aspects, get out of your comfort zone. Members of teams must know their own jobs, but they also must learn about the jobs of those around them. Therefore, stay curious. Of course, all those key learnings can be extended, so it's just a list of us. Probably you've already had the same experience, and therefore, yeah, let's come to an end of our story. We hope you enjoyed it. Thank you for the attention, and we are open to questions.
Thank you so much, Michael and Patrick. So we do have some questions. I have one. So you talked about the mindset problem in the change. So would you have any advice to help teams to shift the mindset and how to do it?
Actually, first of all, I guess it's an easy advice. Don't give up. So we really saw that we had some kind of mixed teams, guys which were developing for 20, 30 years. And then some youngsters were joining the team. We had different cultures. We also had different cultures in terms of different countries, guys from UK, from Croatia, from Austria, from Turkey, and so on. And really had lots of sessions. And at the end, we did it as a team. So really had all those kind of phases, these norming, storming, performing phases. So we really suffered, but but we also got some good aspects from it. So we learned each other as a team, how we can collaborate. Because we really started with this kind of, I think the term silo approach. So each guy was having his own component, just doing his development work, and there were no interfaces between those silos. And by getting these new roles, so specifically having an agile coach, having an agile a scrum master, this guy were really trying to strengthen the communication skills for the guys. So at the end, I think we have now a great team. The oldest guy is about 63, the youngest guy is about 29. And we did it, but we really had all those phases which you can maybe read in the literature when becoming a Scrum team. So I can't explain new advices, but we had all those issues, of course, during our journey.
And we've arranged from Poland to UK, according to
UK and Austria, right? in our case, that's true. So and online, and so we also have because guys are working from remote all the time, even before Corona. So also we had the challenge that we had to include those guys staying at home or staying online.
Yeah.
All the time. But
thank you.
I think we did it. We did it.
Yeah.
So we're still there, as you can see.
Thank you very much, Michael,
Thank you.
Patrick.
Thank you too. Thank you, Nina. Thank you, Silas.
Thank you. Thank you.
Bye.
Bye.